Hi, I'm Dr. Rob Silverman, Amazon bestselling author of Immune Reboot. I'm excited to be sharing some insights on methylation, MTHFR, and histamine, the interconnection. So many patients ask me, what is methylation? Well, methylation is the addition of a methyl group on a substrate. Methylation can alter genes' expressions. During this process, chemical tags called methyl groups attach to a particular location within the DNA where they turn a gene on or off, thereby regulating the production of proteins that particular gene encodes. This methylation provides DNA repair, protein function, and gene expression. The primary role of methylation is to recycle an amino acid on the homocysteine to keep it at levels that are healthy and optimum ranges. Methylation, or the process of methylation, occurs in every cell of the body. In fact, it occurs billions of times every second. Approximately 50% of the population can't methylate due to this MTHFR gene or a mutation of that MTHFR gene expression. So it really begs the question, and I'm asked this all the time, what is MTHFR? Well, that's a gene that provides the body with instructions for making an enzyme called methylene tetrahydrofolate reductase. That is, without question, a mouthful. A variant in your body, in my body, may lead to low folate and B vitamin levels. So how does this MTHFR affect methylation? It's a very commonly asked question. The answer is simple in that the gene's function is responsible for creating multi-step chemical breakdown process called methylation. MTHFR deficiency results in reduced methylation capacity and alteration of inflammatory mediators. An MTHFR gene test is one that I recommend everybody take because it's so revealing. You use a blood sample to look at two very common changes in the MTHFR gene. A change in this gene is called MTHFR variant or mutation. These variants are called single nucleotide polymorphisms, or more commonly referred to as SNPs. MTHFR gene test. These MTHFR gene mutations cause the gene to work less effectively. Dysregulation of MTHFR gene is associated with hyperhomocysteemia, cardiovascular disease, neural tube defects, and impaired cognitive functions. It can also cause issues with detoxing, adversely affect our liver detox pathways, issues with hormone balance, immune system function, and can lead us down a slippery slope towards autoimmune conditions like fibromyalgia, Hashimoto's, and even lupus. Interesting, there are two main gene variations. The number is very simple. It's C677T variant. The C stands for cytosine, is replaced by thymine, the T, at the position of the 677 of the MTHFR gene. This results in an amino acid change. Alanine is replaced by valine. The second MTHFR variation, A1298C, adenine, is replaced by cytosine. This results in amino acid change. Glutamate is replaced by alanine. If both copies of the gene is involved in a variation, they're called homozygous. If only one copy, it's heterozygous. A lot of my patients ask me, can you make sense of this idea of methylation? I like to use a metaphor. My metaphor is a car on an assembly line, ready to go. The only thing left with this brand new car with its body in perfect condition and its engine functioning optimally is 4 tires full of air. Those tires are metaphors to methyl groups. As long as you can methylate correctly, you can put the tires on the car and the tire goes from point A to point B efficiently out of the assembly line. Unfortunately, if you can't methylate, if you have variants or mutations, they're like flat tires. The car does not run efficiently and ultimately damages the body or the engine to the car. So it's very clear that methylation is critical for overall body function. Continuing with MTHFR linked to high histamine, how does this occur? The MTHFR gene converts folic acid into its active form, methylfolate, which is required for proper methylation. The MTHFR gene mutation means that you have compromised methylation. Methylation is needed for proper functioning of two different enzymes. Enzyme number 1 is HNMT, and enzyme number 2 is COMT. MTHFR and insufficient methylation lacks enough methyl for those above enzymes, causing a buildup of histamine. That's an overview. Histamine increases the hormone estrogen. Estrogen regulates an enzyme called DAO, which degrades histamine in the gut. Methylation, with a form of choline, makes bile acids. Bile acids are critical. Proper bile acids enable you to avoid high incidence of SIBO and leaky gut. Unfortunately, conversely, decreased bile acids lead to a higher increase of small intestinal bacterial overgrowth, or, if you will, SIBO. SIBO causes inflammation and histamine released in the small intestine. DAO becomes overworked. HNMT enzyme will take over. Without methylation, HMMT enzyme will not function optimally. Therefore, insufficient methylfolate. Choline is now substituted and used for remethylation of homocysteine. If you have insufficient choline, you're going to get a decrease in bile acids. Histamine and inflammation, they are interconnected, they are intertwined. Most people are not aware that histamine actually facilitates a role in brain and neurotransmitter function, digestion, food allergy intolerances, mental behavior disorders such as bipolar, OCD, ADHD, and actually even schizophrenia. Let's talk about some histamine fundamentals. It plays a vital role in immunity. It directly affects symptoms of seasonal and food allergies. It will activate or rev up your immune system, make it hypersensitive. Additional histamines in environment or food sources create an overload of histamine in the body and cause too much inflammation. Too much inflammation occurs. You need to use outside influence to turn down histamine overload, known as histamine intolerance. H1 receptors associated with allergy reaction function and H4 receptors. They direct immune cells towards the source of histamine in inflammation hotspots. Histamine also plays a role in digestion. It stimulates stomach acid, which we know is the first line of defense against bugs, which are essential for breaking down food in proper nutrient absorption. There are bacteria that naturally live in the body and produce histamines. If we have bacteria overgrowth, digestive dysfunction like IBS, Crohn's, leaky gut, or dysbiosis, this all may occur because of the result of a histamine intolerance. Histamine plays a role in the brain and the nervous system. Interesting, its role in the nervous system is much more complicated. Histamine, as a neurotransmitter, works to control the sleep-wake cycle. It may decrease GABA levels and increase norepinephrine and epinephrine levels. And lastly, histamine may cause increased permeability of the blood-brain barrier. The blood-brain barrier, single-layer epithelial barrier that actually filters 400 miles of arteries of blood from your brain. It is the doorway that can be opened to your brain. Continuing with the idea of histamine imbalance or intolerance, any of the systems, immune, stomach, or brain cells, can release histamine when the body demands it. If the process shifts out of balance, too much histamine is released, initiating inflammation caused by allergies. Some of the subsequent things that occur from these allergies are digestive dysfunction, like IBS, dysbiosis. Dysbiosis is the unleveling of good and bad bacteria. We need about 85% good bacteria to avoid dysbiosis, SIBO, reduced gut integrity, and any body chemistry or functional imbalance. To reduce the effects of histamine intolerance, it's necessary for inflammatory responses to occur as soon as possible and to take action. Histamine breakdown. As we said before, to reiterate, two enzymes that control histamine breakdown. If either one of the enzymes isn't working well, histamine escalates dramatically in the body. HNMT, which is histamine N-methyltransferase, is a main histamine degrading enzyme in the brain. HNMT breaks down histamine inside cells without being released into bloodstream. It also resides in the liver, the spleen, the gut, the prostate, ovaries, kidneys, and even in the lungs. HNMT breaks down histamine through methylation. Individuals with high blood histamine classified as undermethylators, and those with blood histamine are classified as overmethylators. Maybe other causes that contribute to undermethylation that can raise histamine levels, like reduced DAO activity, elevated histamine production, other sources of histamine intake like environment, food, etc. DAO It's an enzyme that's primarily used for the gut, connective tissue, placenta, and kidneys. DAO is released into the blood, impacting the breakdown of histamine, which is found outside of cells. DAO also promotes breaking down spermidine, which is a specific type of amine. Histamine receptors is a critical theme for overall histamine effectiveness. Histamine is released in the body upon mast cell degranulation, which may be received by one of four receptors. They're signified by H1R to H4R. Most understood, most accurate at this point are H1 and H2 receptors. Let's go through these different receptors and what they do for the body. And H1R is found throughout the body in smooth muscle, vascular endothelial cells, heart, and central nervous system. An H1 antagonist is an antihistamine. H2R triggers gastric secretion of histamine to regulate HCl production. H2 receptors are medications traditionally prescribed for acid reflux. H3 is found mainly in histamine-releasing nerve cells in the brain and cells in the stomach. H3R prevents histamine release and may oppose activity of other histamine receptors. H3R promotes sleep and helps reduce itching. H3R is found to lower acetylcholine, dopamine, serotonin, GABA, noradrenaline, and glutamate. H3R promotes alcoholic preference. It actually may want you to drink more. H4R is found in bone marrow and white blood cells. It's also found in small amounts in the spleen, the thymus, the lung, the small intestine, the colon, and the heart. H3R prevents histamine release and may oppose activity of other histamine receptors. H4R activates white blood cells involved in inflammatory responses. And lastly, H4R is responsible for cytokine release. Let's review histamine functions and its breakdown from the body. H1 receptors, smooth muscle and skin cells, they are vasodilators. H2 are acid secretion, they increase heart rate, they also lead to muscle relaxation. H3 are central nervous system, sleep, and behavioral modifiers. H4 comes from mast cell production, white blood cells, and usually has an inflammatory responsibility. So histidine has HDC, which makes histamine, which leads to DAO, which functions outside cells in the bloodstream. Also, if you would have this flow chart, which you should probably be looking at right now, HNMT functions inside the cells in the central nervous system. So what is histamine intolerance? Not a sensitivity to histamine, but an indication that the body has developed too much histamine. So how do you keep histamine in check? Well, the body produces enzymes known as diamine oxidase that keeps your histamine levels in check. If DAO enzymes are not sufficient, histamine will not break down properly, and excessive buildup and histamine intolerance takes place. DAO enzymes produced in the kidney, thymus, once again, the small intestine. Let's talk a little bit about the histamine intolerance pathway. Histamine travels throughout the bloodstream and can affect gut, skin, brain, and cardiovascular system. It contributes to a wide range of symptoms, often making histamine intolerance difficult to pinpoint and diagnose. So let's list the litany of symptoms of histamine intolerance. Number 1, digestive dysfunction, acid reflux, abdominal cramping, leaky gut, small intestinal bacterial overgrowth, nausea, vomiting, not having a gallbladder, fatty liver, headaches, migraines, and even brain fog, nasal congestion, sneezing, difficulty breathing, fatigue, anxiety, irritability, tissue swelling, hypertension, irregular heart rate, abnormal menstrual cycle and severe cramping, difficulty regulating body temperature, thyroid dysfunction, skin rashes, eczema, hives, and lastly, vertigo and even dizziness. So many of my patients ask me, what foods contain histamine? Well, here you go. Booze, most commonly wine and champagne. Canned seafood, canned dried salted seafood like sardines, mackerel, tuna, and anchovies. Aged cheese like Parmesan cheese, fresh cream, and cottage cheese are actually lower in histamines than Parmesan cheese. Aged and smoked meats, bacon, salmon, ham, and salami. Those leftovers, reheated leftovers of meal prep kits are typically high in histamines. Chocolate and some spices like cinnamon, clove, curry, cayenne, and nutmeg. Fermented foods, though they're healthy, are high in histamine like kefir, kimchi, yogurt, and especially sauerkraut. Certain legumes are also high in histamine. Soy is a major culprit. Green peas, red beans, sugar, and sweet peas. Safe beans to eat would be a lima bean, a pinto, a white, navy, black bean, black-eyed peas, lentils, and chickpeas. Certain nuts are high in histamine, like walnuts, cashews, and peanuts. I know peanuts are more a cousin to a legume than a nut. Classify them in the nut section anyway. Certain vegetables, spinach, avocado. Avocado can also be considered a fruit. Eggplant, tomatoes, and mushrooms. Certain fruits, pineapples, papaya, strawberries, bananas. Vinegary foods like pickles, mayonnaise, olives. Seafood and crustaceans like squid, mussels, shrimp, crabs, prawns, all are very histamine rich. Foods that create excessive histamine, tremendous liberators of histamine and trigger the body to produce histamine. Certain fruits and vegetables like most citrus fruits, strawberries and other berries, tomatoes. Once again, nuts and cashews. Chocolate and cocoa, tomatoes, tomato juice and ketchup. Additives like dyes and some preservatives. Alcoholic beverages of all kinds. Food additives such as sorbates, sulfites, and food flavor enhancers. Here's a wow. 30 to 55% of people with digestive symptoms or conditions like IBS, IBD, and Crohn's disease have histamine intolerance. Just to put it in a nice tight bow, let's take a look at histamine. It can cause blood clots, increase gastric acid secretion, blood vessels to dilate, bronchial constriction, increase permeability of the capillaries. It will release excessive amounts of adrenaline. It will lead to swelling and inflammation, and it will increase your heartbeat or have a frequent heartbeat. And lastly, let's look at the different systems that histamine work with and can have adverse effects on, like the central nervous system, your coronary pulmonary system, skin, respiratory, uterus, GI, and also bone marrow. Well, I hope you enjoyed that conversation about methylation. But for me, the big takeaway in summary about methylation is that over 50% of Americans do not methylate appropriately. They're under or over methylators. So you've got to test for the MTHFR gene to see where you are. You only have to test one time. Now, what's interesting is I use a test on all my patients, as I said before, because it allows me to understand their ability to methylate. If they're unable to methylate appropriately, once again, like the metaphor we used, that car is not going to run. But deeper than that, I'm a big proponent of functional medicine. And functional medicine's mantra is that we believe that you have to get to root cause resolution. Now, we talked about a lot of things that methylation could cause, like SIBO, leaky gut, increased histamine, damage to the blood-brain barrier, all very deleterious to any one of your patient's overall health. Unfortunately, most people, when they test for leaky gut, when they test for SIBO, or they test the blood-brain barrier, find it and treat it. And well, they should. But in the realm of root cause resolution, methylation may be the root cause resolution of a lot of these functional medicine themes, meaning that because you don't methylate and you don't take the test to see if they have the gene, if they're over and under methylator, you're missing the root cause. So at the end of the day, one of the first things I would recommend for any practitioner is to test to see the status of your patient's MTHFR gene so you can rule in and out its impact on high histamine, digestive problems, central nervous system problems, and brain problems specifically. So I hope you found this informative. My name is Dr. Rob Silverman, always yours in health.